Thermal expansion is a tendency of matter to change its shape, area, volume, and density in response to change in temperature. Temperature is a degree of hotness or coldness of a body. Its SI units are degrees Celsius and Kelvin. Thermal expansion can be illustrated using different kinds of experiments. The first one is the heat and ball and ring experiment. In this experiment, a metal ball is used and it is passed through a ring. Initially, the ball passes through the ring with ease. Later on, when you hit the ball, when the ball is heated strongly from a source of heat, for example, a Bunsen burner, the ball is heated for a period of about 3 minutes. On hitting the ball, it is observed that thermal expansion takes place, and when you try to pass the ball again through the ring, as it can be seen, it is seen that the ball is not able to pass through the ring. This is because thermal expansion have occurred and the ball have increased in volume. Therefore, it cannot be able to pass. On cooling the ball, or cooling the metal ball, on this case we cool the metal ball using cold water. Now the ball is cooled by passing it through cold water, and then we try again to pass it through the ring. This time it passes through the ring once again. This is because it have cooled and therefore it has gained its initial state. Another example is the use of observing electric cables. Electric cables are wires that are used to transmit electrical energy from one place to the other. Early in the morning, when the temperatures are low, the wires are straight and are tightened. This is because there is low temperatures and the wires have contracted. And that is why the wires have contracted and they appear to be straight. During the day, as the temperature increases, probably maybe because of the sun, the material of the cables expands thermally because of the increased temperature. The increase in temperature can soften the material, reducing its tensile. This leads the wires to sag as a result of slightly elongation as a result of the increase in temperature. The tensile strength, which leads the cables to increase in volume, leads to the cable increase in weight, and therefore they are prone to sagging. To counteract this effect, the electrical transmission cables are designed with allowances for sagging and empty tension to prevent excessive sagging. Another application of thermal expansion is the construction of bridges. In designing of the bridge, the designers takes into consideration of thermal expansion to ensure that the structure can accommodate temperature fluctuation without causing damage or the structure failure. Since the materials used, for example steel and concrete, expand and contract with the temperature change. A bridge is designed with an expansion joint as seen. This is a gap between the sections of the bridge that allow for movement. They can be filled with rubber to provide flexibility while still maintaining structural integrity. Whereby, when thermal expansion occurs, instead of bridge breaking, it fills the space. Still, on the construction of the bridge, the designers make it that the pillar and the beam are not connected. There is a space that is left between the beam and the pillar of the bridge. This space allows the beam to slide over the pillar when the temperatures increase and the beam has expanded. When expansion occurs and the beam has expanded, it moves horizontally, which can make it to break, but when there is an allowance, the bridge cannot crack. Also, the other side of the bridge that is fixed to the other side of the road is not connected to the beam, so that when the bridge has expanded, it will be able to move horizontally with ease. This minimizes all the risk of cracking, because there is an allowance that has been left even at the top side of the bridge, and therefore the beam cannot crack. Thermal expansion involves also the contraction, that even when the contraction have taken place, the bridge will move and get back to the initial state without cracking. Also, on the edge of the bridge, it is designed that the beam that supports the bridge and the vertical block have a spacing that is filled when expansion takes place. And when cooling takes place, the beam has some allowance. Therefore, this helps the bridge not to crack or to be damaged, and therefore that is why the designers of this bridge has left the space so that it can be filled when expansion and contraction are filled. When viewing the spacing from the top side of the bridge, this allowance can be clearly seen. Choosing materials with known thermal properties such as steel and concrete allows engineers to predict and accommodate for thermal expansion. Another application is the construction of the railway track. There is a joint joining two pieces of rail, as seen. The yellow part indicates the place that the joint has been placed. This joint is majorly constructed because of expansion and contraction due to change in temperature. There is a fish plate joining the two rails together in the joint. The blue part indicates the two rails, while the yellow part indicates the fish plate, and the center part is the joint. And this is a working of the joint expansion cycle. The switch plate is the one that joins the two rails with nuts and bolts. They are designed in such a way that they can allow the rails to move easily. This is a working of joint expansion cycle. The switch expansion joint is used to the expansion in long wounded rail. The holes of the fish plate are designed in such a way that when the rails expand, they can move and extend from one point to the other. The switch expansion joint can be connected in one side or in both sides. It depends on temperature variation throughout the day or seasons of the year. The switch expansion joint is made up of two rails. That is the stock rail and the tongue rail, which slide on one another. The stock rail is the one painted on blue, and the tongue rail is the one painted on red. The tongue rail is designed in such a way that it slides over the stock rail. In the case when the switch joint is put on both sides of the rail, the tongue rail is put between the two stock rails, which enable it to slide with ease. And that is the application of the construction of railway tracks.